right, so today we're starting with 6.1. And this is solving systems by graphing. All right, so first of all, we have to know what a system is. So a system of equations is equations with the same solution. So this could be two or more equations that all have the same exact solution. And that solution is going to be written as a point x, y. It's always a coordinate point. All right? So, when you are graphing today, and again, we're doing it by graphing, if you have two lines that intersect each other, where they intersect right here is your solution. Okay? When they intersect, this is called, we'll actually put lines intersect. There is one solution. That solution is your xy point where they cross. And this type of system is called independent. Option number 2 is if you graph a line and then you graph another line directly on top of it, so same lines, these have infinitely many solutions, and these are called dependent. We have one more type of system we're going to talk about today. Let me make sure everybody's got that down before I move it at all. The third type of system is if the two lines never intersect. That is no solution. Very good. So these are parallel lines. They never intersect. And there is no solution. And we call this type of system inconsistent. So today when you're graphing, excuse me, you're either going to find where they cross. If they're the same line, you write infinitely many. Find your notebook. There you go. Okay. All right. So we have three options. One, if the lines intersect, we have one solution. If when you graph them, one line is on top of the other line, it's infinitely many. And if the lines are parallel and never cross, it's no solution. All right? So you have three options. Do we have any questions before we proceed? Okay. So go ahead and for example number 1, I want you to put your first sticky graph in there. That's all right. All right. So, again, we said it's two or more equations that have the same solution. Remember when you put your graph in, it's y to the sky, right? All right. So we're going to start by graphing the very first one. When we graph y equals 3x minus 4, where do we start? -4 on the y-axis. We start at the point 0, -4. So on the y-axis, we go down 1, 2, 3, 4, and put a dot. From that dot, we're going to move our solution, or our slope, excuse me. We're going to move our slope, just 3 over 1. Good. Seth says we go up 3, 1, 2, 3, and to the right 1. Please repeat it again. Up 3, 1, 2, 3, to the right 1. Each and every one of you have a straight edge on your desk. You are required to use it today. Please connect those dots with your straight edge. So that's a straight edge. All right, second equation. The second equation, we start with that last number again, which is the point 0, 1. On the y-axis, we go to +1 and put a dot. Our slope is -2. That means we're going to do what, Mackenzie? Very good. We're going to go down 2 from our y-intercept, down 2 to the right 1, down 2 to the right 1. Connect our dots. Do our lines intersect? Where do they intersect at? Good. That is our solution. If we were to plug 1, -1 back into either of those equations, they would work. So if I plug 1 in here, 3 times 1 is 3, -4 is -1. -2 times 1 is -2, plus 1 is -1. So that solution works for both equations. That's independent, yes. Now, you're not going to have to name them today, but I did want you to know what they were called for future reference. Okay? All right, so we're good on the first one? Okay. Example number 2. So go ahead and put your next sticky in there. Oops, I want that. That's fine. All right, this time, let's say I have, so 2x minus 3y is -5, and 4x minus 7y? Oh, I don't know. How about we just say y equals +5. All right. Had to make sure it works in my head. So, what are we going to do with these? Yeah, you can either do intercepts, but you'll notice that these intercepts would be fractions. And if we want to make sure they're going to land exactly in the right spot, we probably should change these to y equals mx plus b. Because, you can't have an exact fraction and be right on, right? So, we're going to get y all by itself. In the first one, how do I get y by itself? I first do what? Good. So I have -3y equals -2x minus 5. Now what do I do? Good. I'm going to divide everything by -3. All right. I get y equals a negative over a negative is a positive 2 over 3x. And a negative over negative is a positive 5 over 3, which we ended up with a fraction. But. All right, how about the other one? Oh, actually, let's graph that one first. 5 over 3 is actually 1 2/3. So we're going to start at 1 2/3 on the y-axis. All of them will be whole numbers on your worksheet today. All right, our slope is up 2 and over 3. So we're going to go up 2, 1, 2, and to the right 3. 1, 2, 3, and put a dot. Up 2, 1, 2, and to the right 3. 1, 2, 3, and put a dot. Go ahead and connect your dots. All right, let's do the other one. The other one I need to get y by itself, so the first thing I do is what, Andrew? All right, so we're going to subtract 4x to the other side. So I have negative y equals negative 4x plus 5. Is y by itself yet? Okay, what do I have to do? All right, divide every single thing by negative 1. I get y equals a negative over a negative is a positive 4x minus 5. Very good. So that means, Seth, I'm going to start where? Negative 5 on the what? On the y-axis. 1, 2, 3, 4, 5. Put a dot right there. From that dot, I'm going to do my slope of 4 over 1. That means we do what, Trenton? Very good. 1, 2, 3, 4 over 1. I'm going to repeat it. 1, 2, 3, 4, and over 1. Connect my dots. Do these two lines cross? Where do they cross at? 3, 2. Try it again. 2, 3. That I agree with. Make sure you go x and then y. 2, 3. Yes, I agree. All right, so questions so far? All right, now I'm going to give you a couple other little graphs for our next couple, but you're going to have to draw your own axis on them. So they're a little bit different. Here, we'll kind of split it. You want to take half of a room, give them 2 of these. They have stickies down both sides. You guys have to draw your axis on these. They're a little bit harder to get apart, but like on both, they're Post-it notes on both sides. Does that make sense? Yes. There's 1, 2. Thank you. There's 2 for you. You're welcome. Thank you. Ah, 2 for you. All right. I need a few more. I know. Thank you. Nope, actually, Bella needs 2, and these guys need 2. Okay, and then that's it. Yep. All right, here we go, you guys. So, example number 3. Go ahead and place that in there and draw your axis on it. Yeah, I do. Hold on. See if I have any more in here. If not, give her a big one. Okay. I don't know. Oh, yeah, there's. Here, those are big. Huh? I don't care. Go ahead. All right, here we go. Example number 3. Put that in there. And draw your axis just like I do. All right, this is example 3. Let's go with x plus y equals 4. And x plus y equals negative 3. So now we can do this one by intercepts, because when we divide over, there won't be any fractions, or we can get y by itself. Which way do you guys want to do this one? Get y by itself. All right. You can do it your way, too. Both work just fine. For this one, if we get y by itself, we're going to subtract x to the other side. So I have y equals negative x plus 4. If we do it by intercepts, it's going to cross the x and y axis at where? 4. All right, if I graph this one, I'm going to start at 4 on the y-axis, and my slope is a negative. So that means I'm going to do what? Good, down 1 to the right 1. So from our y-intercept, we go down 1 to the right 1, down 1 to the right 1. If I keep going, guess where it's going to cross the x-axis at? At 4, where Joel said our x-intercept was. The other one, if we get y by itself, I'm going to subtract x to the other side. So I have y equals negative x minus 3. So this time, I start at negative 3 on the y-axis. And my slope is a negative again. So I go down 1 to the right 1. Down 1 to the right 1. So we're going to connect our dots. What is our solution on this one?
No solution.
Very good. This is no solution. Because they are parallel lines, they will never, ever cross. All right. Last example for today. Go ahead, example 4. Put your last little sticky that Ms. V gave you. Okay, or I gave it to you. Example number 4. All right, everybody's got that in there? All right, let's say we have negative 3 minus 5x minus 3y equals 0. And negative 3y minus 5x equals 3. So both of those equations are not in slope-intercept. They're not in standard. They're not in anything. So what do you think we should do? Go to standard? That's an option. We can go to standard. We can go to y equals mx plus b, which I think... Okay, so let's go to slope-intercept. All right? So on the first one, we need to get y by itself. What do you want to do first, Joel? Okay, so Joel wants to move negative 3y to the other side, so we're going to add it. I'm going to write it on this side, though. 3y equals negative 5x minus 3, because I like to put it in that order, right? Then I have to divide everything by what? Divide everything by 3. All right, so I get y equals negative 5 over 3x minus 1. So we're going to start at negative 1 on the y-axis at the point 0, negative 1, right here. My slope is negative 5 over 3, so what do I do? Good. 1, 2, 3, 4, 5, and 1, 2, 3, and put a dot. Go ahead and connect our dots. Now, one of the things that Joel always points out is we can actually do that in reverse. We can go up 5 and put the negative on the bottom. If we go up 5, 1, 2, 3, 4, 5, we have to go backward 3. Yeah. All right. So on this one, the other equation, we need to get y by itself. So the first thing we're going to do is add 5x to the other side. So I have negative 3y equals 5x plus 3. Then I have to divide everything by negative 3. Very good, you guys. So you get y equals negative 5 over 3x minus 1. It is the same thing, isn't it? So what's our solution, Joe? Yes, good. All right. It is infinitely many solutions. Good job, you guys. Do we have any questions? One requirement I have today is that you have to use a straight edge to connect your dots. It has to be a straight line to be able to see where they intersect. Okay? All right. We are going to get you your worksheet.